This presentation is for the International Conference on Computational Science and Computational Intelligence. The title of the presentation is Converting WOX Objects to YAML Documents. The authors of this work are Vivian Reynoso-Sánchez, Betzabet García-Mendoza, Carlos Roberto Jaimez-González, and Wulfrano Luna-Ramírez. We are from the Information Technology Department of the Metropolitan Autonomous University in Mexico City. This presentation is divided in the following sections. First, I will explain the concept of serialization and deserialization. I will also give you some considerations for representing objects. Then I will talk about some formats for representing objects. After that, I will give you the background of this work. Specifically, I will talk about the WOX framework. Next, I will introduce YAML, its data types, and some examples of documents. Then I will describe some existing tools to convert XML documents to YAML documents, and I will provide a summary in a comparison table. After that, I will show you the operation of the WOX to YAML converter and provide some examples of conversions from WOX to YAML. Finally, I will give you some conclusions and future work. Serialization is the process of converting an object to a form in which it can be stored in memory, in a file, in a database, or in a stream to be transmitted over the network. The main objective of serialization is to save the state of an object to later rebuild it when it is required. In the diagram of this slide, we can look at this process. We can see an object being serialized to a particular format and then stored either in memory, in a file, or in a database. Now, the inverse process is called deserialization, which consists, as we can see in this diagram, in taking the representation of the object from memory, or from the file, or from the database, or from the network stream to reconstruct it in an object. Many programming languages have serialization support included as part of the language or through some library. That library or program is called a serializer. Here I provide some examples of programming languages that have serialization support built into the language: Java, Python, Ruby, PHP, among others. In an ideal situation, the serialization and deserialization support included in programming languages would be enough to represent the state of an object, which contains data types and basic language structures. But in some programming languages, serialization is partially done, since they don't allow more complex structures of the language to be represented in the object state, such as pointers or references to objects, collections, enumerations, and others. Now, concerning distributed systems, serialization and deserialization are widely used processes. This is because data exchange is required. As an example, we can imagine passing an object to a remote application through a web service or a remote procedure call. In the same way, there are applications that require exchanging objects and are written in different programming languages. So it's necessary that there is a language-independent representation of objects, that is, a standard format to describe serialized objects. Well, there are some considerations that must be taken into account to represent objects. It's not a simple process. Note that objects must be properly restored in terms of their single or multiple inheritance. Complex data structures must be properly reconstructed, mainly where an object could be referenced multiple times by several pointers or references. Collections of objects have to be also restored appropriately. For example, lists, dictionaries, enumerations, among others. Another consideration to take into account is the size of numeric data types. Now, let's talk about the background. The work that we are presenting today has its background in the framework called Web Objects in XML, WOX, which was created to manage distributed objects and web services. WOX is a framework that we have developed in the past years. Initially, it only had the functionality for the creation and management of remote objects and web services. Currently, it has relevant features for the area of distributed systems and in particular for interoperability between systems. I would like to mention that WOX and its components have been used to support the teaching of some courses of the undergraduate degree in Information Technologies and Systems at our faculty. In particular, it has been used in the courses of Distributed Systems, Systems Integration, and Thematic Laboratories. WOX is a framework that uses HTTP protocol for communication among clients and servers. It uses XML as the format for representation of serialized objects, and it keeps objects available through their own identifiers, URLs. When the serialization process takes place with the WOX framework, the object is converted to XML in a representation that is independent of the programming language. Notice that the root of the XML document presented in this slide is an object element with its attribute type equals product, which is the class of the object. The ID attribute is used to handle object references. In this case, it's only one object. Each attribute is in the object is represented by field elements, which have the following attributes: name, which is the name of the attribute in the class, type, the WOX data type of the attribute, and value, the value of the attribute for that particular object. This is the XML representation of a product object. Now, given the importance to convert from WOX objects to YAML documents, we will start by describing YAML and its data types. YAML is a data serialization language, which is human-readable and easy to understand. It can also be used together with other programming languages and is often used to write configuration files. YAML is often related with XML, but YAML is not a markup language. It is an interoperable, flexible, and object-oriented language. On the other hand, XML is an extensible markup language that was designed to be backward compatible with the standard generalized markup language. Therefore, it had many design restrictions that YAML doesn't have. For example, XML is designed to support structured documentation. YAML is more focused on data structures and messaging. YAML supports various data types such as arrays, dictionaries, lists, and scalars. The format of YAML is case-sensitive and space-sensitive. In YAML, it's possible to store primitive data types such as int, float, string, boolean, and null. This slide shows an example of the representation of these types of data. The first attribute in this slide, or key, is name, which is a string and must be enclosed in single or double quotes. H value is an int data type. Height is a float data type. Merit is a Boolean data type with two possible values, true or false, and children has the new value. Multi-line and single-line strings are also possible in YAML. The string is simply a long string, which is divided into several lines. With this notation, the interior line breaks are eliminated. This figure shows an example. A list in YAML is a sequence of objects. It's an ordered collection of values. These values are not associated with a key, but with a positional index obtained from the order in which they are specified in the list. This slide illustrates the way in which the lists are represented in YAML. A list can contain any number of elements. Each element in the list is indented by a number of spaces and is preceded by the hyphen symbol. YAML represents an array as a group of values arranged in sequence. This slide, for example, shows an array of 4 elements in YAML: element 1, element 2, element 3, and element 4. This is the representation of an array in YAML. Objects in YAML are represented as a group of key-value pairs. This slide shows some valid expressions of key-value pairs: Germany, Berlin, Spain, Madrid, France, Paris, and Italy, Rome. This is the YAML representation of some key-value pairs. In this work, we have compared 5 different existing tools that are similar to the converter that we developed: online YAML tools, JSON formatter, doc converter, browser link, and XML plain. Online YAML tools is a website that contains an XML to YAML converter. In order to use the converter, the user enters the XML in, and then the YAML will be obtained in an output box. JSON formatter is also a website that helps to convert XML to YAML. In order to convert the data, the user has to write the XML in an input box, and the YAML is automatically generated. Doc Converter is a Java library that allows converting XML, JSON, CSV, and YAML formats. This library contains a doc converter class that can be called to convert between formats. BrowserLink is a website that hosts a simple XML to YAML converter. All the user needs to do is to type or paste the XML into a text field and press the button to get the YAML generated. Finally, XML plain is a module in the Python programming language that converts XML to YAML and vice versa. It only allows to convert simple and data types such as lists, dictionaries, and strings. This table shows a comparison of the tools analyzed: online YAML tools, JSON formatter, doc converter, browser link, and XML plain. A tick indicates that the system has the feature, while a cross indicates that the system doesn't have it. The features considered for the comparison in this part of the table are the following. The web application feature indicates that the tool can be accessed through a web browser. The interoperability feature refers to the ability of the tool to exchange information, whether data, documents, or objects, between different programming languages. The Save YAML feature refers to whether the tool has the ability to save the generated YAML document. The Validate XML feature indicates that the tool is able to check that a document in XML format is well formed and conforms to a specific structure. This is the second part of the comparison table, which shows other features considered. The example feature means that the tool has examples about XML and YAML. The upload file feature refers to whether the user can select the document hosted on the computer to be uploaded to the tool. The input text feature refers to the existence of a text area that allows the user to enter or paste text. The structure YAML feature means that the elements of a YAML document must follow a structure and have an indentation. The web application developed has all the features described in the previous table. It is a web application. The converter allows interoperability between WOX and YAML. It allows to save the YAML document in a file. It validates the XML input. It will contain several examples to convert different types of WOX objects to YAML documents. It's possible to upload XML files to the web application. It has an input text to write the WOX object, and it generates a structure YAML. Well, this is a screenshot of the web application developed, which has two text areas, as we can see. The left text area is to write the WOX object to be converted, while the right text area is to display the conversion to a YAML document. The interface shows three buttons. The load file button is to allow the user to open a WOX file and load it to the left text area. The WOX to YAML button is to execute the conversion from the WOX format to the YAML format. And the download YAML button is to download the resulting YAML as a document. In this case, the WOX object written in the left text area is an object of the course class, which contains three attributes: code with a value of 6756, name with a value of XML tech, and term with a value of 3. These data types of these attributes are int, string, and int respectively. The YAML document shown in the right text area is the result of the conversion, and it represents the WOX object in a YAML document. We can see there in this right text area all the attributes and values that were extracted from the XML document in the left text area. This slide shows another XML document that represents an array of two product objects in WOX format. Every product has 5 attributes: name, price, grams, register, and category. The WOX data types of the attributes are as follows: string, double, int, boolean, and char. The next slide will show how this object is represented in a YAML document. This slide shows the result of converting the WOX object to a YAML document using the web application developed, which has the WOX to YAML converter. The YAML document generated contains the array of product objects. This presentation introduces a WOX to YAML converter, which allows to translate objects written in the XML generated by WOX to YAML documents, allowing interoperability between applications that use WOX and applications that use YAML to exchange data. The converter presented in this paper resides in a web application that was implemented specifically for this purpose. Its functionality allows to save the YAML document generated in files. It validates the XML input. It's possible to upload XML files to the web application. It has an input text to write the WOX object, and it generates a structured YAML. This paper also provided an analysis of 5 existing tools that translate XML to YAML and describe some of the relevant features. The converter presented in this paper translate XML to YAML, taking into consideration the existing data types in WOX and YAML in order to maintain interoperability between these two text-based formats. The paper also gave an overview of the WOX framework with its functionality and the tools that have been developed to extend it. Further work is needed to complete a website with documentation and examples to convert a variety of WOX objects to YAML documents. It's also planned to put the web application in a server in order to be available for users. There's also ongoing work to develop a WOX to JSON converter. Thank you very much for your attention.